Hey, welcome back to the notes for Algebra 2, Section 7.2. And in this little part of the video here, part of the notes, we're going to learn how to rationalize the denominator of a fraction. Now that's fancy language there, so let me see if I can explain. If you have, for instance, root 3 over root 5, this bottom, if it's got a square root in it or a cube root, is most likely an irrational number. And for historical reasons, and also for simplifying sake, we don't let square roots or cube roots stay on the bottom. You have to get rid of that square root radical. So any square root on the bottom means you got to keep working on it to simplify it. And I'll teach you that skill on the next few problems. Okay, you can see that I have a square root on the bottom. And we're not allowed to leave it there. So what we're going to do here is take the approach we did on the previous section. You're going to put it underneath one square root sign. And then you're going to ask yourself, what perfect square does 7 go into? In this case, 49. So our goal is to make the bottom of 49, and we have to balance that by doing the same on the top that we do on the bottom. So now we have square root of 7x, and the bottom becomes square root of 49. And you can see that that bottom is just going to simplify to 7. So we started out with an irrational number here, and now we have a rational number, and that process is called rationalizing. It's hard to say that word. And it's the bottom that you care about. So it's rationalizing the denominator, and you'll see that direction. Okay, let's do it a couple more examples here. This is not the easiest skill in the world. So here we go. 3x to the fifth. And on the bottom we get 15y. I'm going to go ahead and simplify while I'm at it. So 3 divided into 15 is 5, and you get x to the fifth times 5y. All I did is cancel inside there, 1 there and 5 there. Okay, now I have to ask myself, what perfect square does 5 go into? And we want to make this a 25. And the y, if you bump it up 1, you're going to get a y squared, which will have an exponent that divides by the 2 that's implied out there. Okay, so now we're going to end up with the square root of 5x to the fifth y, and on the bottom, the square root of 25y squared. And hooray, we have a perfect square down here. So that's going to simplify. But we have to break apart the top. Now 5, there's no hope for it. It's not a perfect square. The y likewise. Hang on, I'll get to the y later. This x to the fifth, if you decrease it by 1 and put x to the fourth there and the extra x down here, now you've got a perfect square in the front. And then the y, when the index is less than, when the power is less than the index, then you have no choice but to put it in the back. Okay, the bottom is 5y. That's what we get down here. And by the way, that's why we did all of this up here, multiplying the top and bottom by 5y. And this part in the front here simplifies to x squared. So you get x squared, square root of 5xy, over 5y. Now you have to really be careful here. It's easy to leave something behind. Okay, that one's done. Let's do another example of this. These are both cube roots, so let's make one cube root out of it. Okay, 3, we're trying to make a perfect cube out of 3, and 3 doesn't go into 8, so we'll have to skip that one. Let's see if we can make it a 27. And then x, if you bump it up 2 spots, you'll get x to the third, and it'll work. So now we have cube root of 36x to the third, and down on the bottom here, oh, I made a mistake there. This is x to the second. So I have to change this to second power. And I'll clean it up a little bit here. Second power. Okay, now it's fixed. All right, on the bottom you get cube root of 27x cubed. Okay, the top I don't think simplifies, but we'll discuss it in a second. The bottom is definitely just 3x. Cube root of 27 is 3, and the cube root of x cubed is just x to the first power. 3 divided by 3 is first power. Okay, the top, let's discuss it. 36. 8 doesn't go into 36. 27 doesn't go into 36, so nothing you can do there. And if your exponent is less than your index, you can't do anything about that either. So that top part's done. Okay, moving on to the next problem. What we have in this one is a little bit of a different situation. You can see that there's no cube root up top. We have a cube root on bottom. We're not allowed to leave that. But we don't have one on top to combine. So we fix that in a very sneaky way. We just put a cube root of 1 there. And the cube root of 1 is just 1. So essentially the top 10 is now 10 times 1. But when you do that, you can easily see that that's going to be a 1 over 4x to the fourth. Okay, 4 goes into 8, so we'll try and make that perfect cube work out. And if you take x to the fourth and you bump it up 2 slots, you'll get x to the sixth. So here's what we end up with. 10 times the cube root of 2x squared. And on the bottom here, you have cube root of 8x to the sixth. And now you have 10. And you can't do anything about this back. Nothing will work there. But the bottom now is 2x to the second power. And all we have left to do here is cancel the 5 and the 10, or the 10 and 2, and you end up with a final answer of cube root of 2x squared, 5 cube root of 2x squared over x squared. And we'll pick up on the next problem or two